You walk into a room you have never been in a city you have never visited, and for exactly 2 or 3 seconds, your entire body is certain that you've stood in this exact spot before, certain you already know what happens next. And then, just as suddenly as it arrived, the feeling collapses, and you're left standing there, slightly unsettled, trying to explain to yourself what just happened. You know this feeling has a name: déjà vu. French for already seen. But naming a feeling isn't the same as explaining it. And for most of scientific history, nobody could explain it at all. Here's what should genuinely bother you about déjà vu once you think about it carefully. It isn't vague. It's not a fuzzy sense of general familiarity, like walking into a coffee shop that resembles other coffee shops you've been to. It's sharp, specific. You feel with total conviction that you have experienced this exact sequence of events before, in this exact place, down to specific details. And then, almost immediately, you know that's impossible. You've never been here. This is objectively new. That combination is strange. Your brain is generating a powerful specific memory signal for an event that, by definition, cannot be a memory. So what is actually happening inside your head during those 2 or 3 seconds? For most of the 20th century, the leading theories were, frankly, embarrassing by scientific standards. Some psychologists proposed it was a kind of minor brain glitch, a hiccup where perception and memory got processed a split second apart from each other, tricking your brain into thinking a brand new experience was actually old. Sigmund Freud had his own theory involving repressed, unconscious desires. For decades, déjà vu sat in an uncomfortable scientific limbo, too fleeting and unpredictable to study properly, dismissed by many serious researchers as unfalsifiable. That started to change once researchers found an unexpected doorway into the phenomenon, and the doorway was epilepsy. A neurosurgeon named Wilder Penfield, working in the mid-20th century, was performing brain surgery on patients with severe epilepsy, operating while patients remained awake. Since the brain itself has no pain receptors, to map which brain regions were safe to operate on, Penfield used a small electrode to stimulate different areas of the exposed brain and asked patients to describe what they experienced. When he stimulated a region called the temporal lobe, specifically an area involved in memory processing, some patients reported something remarkable: a sudden, powerful, involuntary sensation of déjà vu triggered on demand by a doctor touching a specific spot on their brain with electricity. That was the first hard evidence that déjà vu wasn't some vague mystical glitch. It was located, it had an address in the physical architecture of the brain, and it pointed directly at the temporal lobe, the same region deeply involved in how your brain stores, retrieves, and verifies memories. This connection deepened further once researchers studying epilepsy noticed something else. A significant number of epilepsy patients report frequent, intense déjà vu experiences immediately before a seizure, so reliably that some patients use the sensation as an early warning sign. If déjà vu in epilepsy patients was being caused by abnormal electrical activity, specifically in memory-related brain circuits, researchers started asking an obvious follow-up question. Could ordinary déjà vu, the kind experienced by people with no epilepsy at all, be caused by a much smaller, much more benign version of the same kind of misfiring? A cognitive psychologist named Anne Cleary, who has spent much of her career specifically researching déjà vu, developed an experimental approach that finally let scientists study it under controlled conditions instead of waiting around for it to happen randomly. She used virtual reality to construct scenes with a specific spatial layout, a garden with a fountain in a particular position relative to a fence, for example, and then later showed participants a completely new scene that shared the same underlying spatial configuration but looked nothing like it on the surface. Different objects, different setting, same layout. Participants who viewed the second scene reported significantly elevated feelings of déjà vu, even though they consciously had no idea the two scenes were spatially related. Cleary's conclusion reframed the entire mystery. Déjà vu, according to this research, isn't a false memory of an entire event. It's your brain detecting a strong structural similarity between a new situation and something stored in memory, without being able to consciously identify what that stored memory actually is. Your brain recognizes the underlying pattern, it just can't locate the specific source. That mismatch, a strong feeling of familiarity with no traceable origin, is what gets experienced as déjà vu. That's a genuinely elegant explanation for the eerie specificity of the feeling. You're not imagining an entire fake memory from nowhere. Your memory system found a real match buried somewhere in your enormous, mostly inaccessible archive of past spatial layouts and experiences, and it's accurately flagging that match. What's misfiring isn't the detection, it's the retrieval. You get the signal without the source. There's a second layer of research that adds something even stranger to this picture, and it comes from a researcher named Akira O'Connor who studies déjà vu using brain imaging. O'Connor's work focused on a specific question. If déjà vu were purely a memory error, a false signal telling you something happened when it didn't, you'd expect it to be associated with brain regions tied to memory retrieval itself, misfiring and generating a false positive. That's not quite what O'Connor found. Using fMRI scanning while inducing déjà vu-like states in a lab setting through a clever variation of Cleary's methodology, O'Connor observed heightened activity not primarily in the memory retrieval regions, but in the brain's frontal regions, the areas associated with decision-making and conflict resolution. This led O'Connor to a genuinely counterintuitive conclusion. Déjà vu might not be your memory system making an error at all. It might be your memory system working correctly, catching a false signal and successfully overriding it. Think about what that would mean. Under this theory, part of your brain briefly, incorrectly, flags a new experience as familiar, likely due to that partial pattern match Cleary identified. But rather than simply accepting that false signal and letting you believe you genuinely experienced this before, a separate part of your brain, the frontal decision-making region, steps in, checks the claim, finds it doesn't hold up under scrutiny, and overrides it. The feeling of déjà vu, that unsettling 1-2 punch of certainty followed immediately by doubt, may actually be you consciously experiencing your own memory verification system doing its job, not a glitch. A successful quality control check happening in real time that you happen to be aware of. This reframes déjà vu almost completely. Instead of being evidence that your memory system is unreliable, it may actually be evidence of the opposite. A properly functioning memory system should occasionally generate false familiarity signals, given how much pattern matching it's constantly doing beneath conscious awareness. What matters is whether those false signals get caught. Déjà vu, under this theory, is the brief, conscious flicker of your brain catching itself. There's supporting evidence for this that comes from an unexpected direction: age. Déjà vu frequency, across large population studies, follows a strange pattern. It's most common in young adults, and it steadily declines as people get older, becoming relatively rare in elderly populations. Even though older adults generally experience more general memory difficulties, not fewer. That's the opposite of what you'd predict if déjà vu were simply a symptom of memory going wrong. If it were caused by memory system failure, it should increase with age, alongside general cognitive decline. Instead, it decreases, which fits far better with a theory where déjà vu depends on an actively functioning, healthy verification system. As certain memory checking processes naturally become less efficient with age, the specific mechanism that produces the déjà vu sensation appears to weaken right along with it. Put together, the picture that emerges is almost the reverse of how most people intuitively think about déjà vu. It doesn't feel like malfunction from the inside, precisely because it usually isn't one. It's closer to a rare, brief moment where an otherwise completely invisible background process, your brain constantly checking incoming experience against a vast, mostly unconscious archive of everything you've ever spatially encountered, briefly becomes visible to you. For 2 or 3 seconds, you get a glimpse of machinery that runs silently, successfully, thousands of times a day, without you ever noticing it at all. So the next time you're standing somewhere new, gripped by that eerie 2-second certainty that you've been there before, you might reconsider what's actually happening. It probably isn't a crack in reality. It probably isn't a memory bleeding through from somewhere impossible. It's more likely the opposite of a malfunction. It's your own memory system quietly and competently, catching itself mid-mistake, and for one strange, fleeting moment, letting you watch it happen. You walk into a room you have never been in, And for 2 or 3 seconds, you feel certain you already know what happens next. You don't, but somewhere just beneath that feeling, some part of you just correctly figured out that you don't and told you so before you even had to ask.